Welcome to the platform of Inside Chemistry, guys. So we are having today's lecture on the topic of effects of substrate, effects of nucleophile, and effect of leaving group, and as well as effect of solvent on SN2 reaction. This is the most important concept of organic reactions and reaction mechanism and organic chemistry. So first of all, let me tell you what is a substrate. A substrate is, a species on which a nucleophile is attack. A nucleophile attack on a substance that is called a substrate. And a nucleophile is a attacking substance, in SN2 reaction. And a leaving group is a group that is leave from a substrate. That is called leaving group. And we had also discussed that what are SN2 reactions in our previous videos. As say in a single step, we can define that SN2 reactions are those reactions which are happened in single step or single mechanism, you can say, and these reactions are also known as bimolecular reactions because here in rate determining step 2 molecules are involved. First is substrate, next is our nucleophile. So let me describe the effects of substrate on SN2 reaction. First of all, in our first point we can say that in SN2 reaction, 3-degree carbocations do not allow SN2 reaction. Here is the point. In this point, you can say that 3-degree carbocations or 3-degree carbon do not allow SN2 reactions. This is the first point that this effect of substrate. If substrate is 3-degree, there will be no SN2 reactions. This is our first point. Why this happened? Because of that in SN2 reactions inversion product is formed. Read this statement that the overlapping p orbital that form pi bonds in vinyl and aryl halides completely block the access of nucleophile to backside of the alpha carbon. You know that this is the most important point of SN2 reaction, that inversion product is formed. If the substrate is SN2, if the substrate is 3-degree, then the alpha carbons do not allow a nucleophile to attack. This is the first point and least point. You can say that this is the most important point, that the alpha carbons do not allow the nucleophile to attack on substrate. That's why 3D carbons, 3-degree carbocations do not allow SN2 reaction. This is the effect of substrate. We can say that 1-degree carbocations are most reliable for SN2 reactions, and then in a trend where we can say that 2-degree carbocations are lesser reliable than 1-degree carbocation, and 3-degree carbocations are the least reliable for SN2 reaction. So this is the effect of substrate on SN2 reaction. Let me describe the effect of nucleophile on SN2 reaction. The point is that the better the nucleophile, the faster the rate of SN2 reaction. You know that if nucleophile will be good, the SN2 reaction will be from a good mechanism. We can say that the inversion product is in a major amount. That is called SN2 reaction. Okay, let me describe. This is a table. You can see this table. Here we have relative reactivity of substances here, and also reactivity is given. The best nucleophile are the best electron donor. That is the last point, that best nucleophile will be best electron pair donor. This is the main point of the nucleophile, or effect of nucleophile on SN2 reaction. So let me describe this table, that what is relative reactivity, and what is, which substance is weak, and which substance is that fast nucleophile. Here are some nucleophiles, that here at the last here at the last you can see that the CN, HS, RS, and all these are very good, and they have higher relative reactivity. That they have very high relative activity. Or throughout the table, you can exaggerate the point, that you can elaborate a point in a single step, that if relative reactivity is higher, then the nucleophile will be very good, and nucleophile will be a good nucleophile. You can say that very good nucleophile if the relative reactivity is higher in a substance. For example, CN has greater than 100 multiplied by 10 power 6 of relative reactivity. And very weak nucleophile you can see here, HSO4, that has less than 0.01 relative reactivity, and rest of all you can see this as the effect of nucleophile on SN2 reaction. So this is the effect of nucleophile on SN2 reaction. Let me come towards the effect of leaving group on SN2 reaction. You know that leaving group is a species that leaves substrate, that is first of all attached to the substrate, but after a few time when nucleophile attack on substrate, it leaves. Okay, this is the definition of leaving group. And the first point is the leaving group usually has a negative charge. You know that it has negative charge. For example, I minus Pr minus Cl minus F minus OH minus RO minus and H2N. This is the this is the first point, that leaving group usually has negative point. Now read the second point, that group which best stabilize a negative charge are the best leaving group. Group which can stabilize a best negative charge can be a best nucleophile. Suppose that here we have I minus, Pr minus, Cl minus, and F minus, and from here any substance that stabilize that have stable negative charge can be a best leaving group. Second point is there. And the third point is weak bases are readily identified. They have high pKb values. Now let see in the table that the pKb values through the group of halogen, fluorine, chlorine, bromine, and iodine. If pKb value is greater, a substance having pKb value larger is a best leaving group. Okay, this is the point. Okay, a substance that have larger pKb value is a best leaving group, and a substance that have least pKb value can be the least that can be not a good leaving group, that can be a bad leaving group, you can say that. This is the pKb value of iodine, that is 23, bromine, that is 22, and chlorine, that is Cl minus, that is 21, and fluorine, that is fluorine minus, that is 11, and HO minus, that is minus 1.7, and RO minus, that is minus 2, and H2 minus, that is minus 21. That is the pKb value of these living groups. So we can say that the higher pKb value, the the good living group is the substance. Iodine is a good living group because iodine is non-basic. A substance which is non-basic is a good living group. This is that point. And the hydroxyl group OH minus is a poor living group because it is hydroxide and it is a strong base. A strong base is a bad living group. That is the point. Now come to the most important part of our lecture, that is the effective solvent on SN2 reaction. You know that solvents are three types. Solvents are having three types: protic solvent, polar aprotic solvent, and then non-polar solvent. Let's see what are the polar solvents effect on the SN2 reaction. The first point is that which contain OH minus, OH ions, okay, and NH2 group. A solvent that contain OH ions and NH2 groups is called as polar solvent, and the polar solvent slows down SN2 reactions. Polar solvent slows down SN2 reaction. And let's see what is the polar aprotic solvent. Sorry, this is the protic solvent, okay, not polar solvent. I had said that this is protic and this is polar aprotic solvent. Like acetone, which contains strong dipoles but no OH minus and NH2 group. You know that in polar aprotic solvent there is no OH and NH2 group. Okay, in protic solvent there is OH and NH2 group. In polar aprotic solvent there are no OH and NH2 group. This is the point. Polar aprotic solvent need speed up SN2 reaction. So this is the main point, that SN2 reactions are speed up by the polar aprotic solvent. Non-polar solvents, for example hydrocarbons, SN2 reactions are relatively slow in non-polar solvents. These are the non-polar solvents. Protic solvents H2O, MEO, and etc. cluster around the nucleophile solvent and lower its energy, stabilize it, and reduce its reactivity via hydrogen bonding. This is all about the reduce of hydrogen bonding and the reactivity. A solvated anion has reduced nucleophilicity, reduced reactivity, and increased stability. A solvated nucleophile has difficulty hitting alpha carbon. So this is all about the solvent, that a solvent containing OH and NH2 group is called protic solvent, and a solvent that do not contain NH2 and OH but it has strong dipoles are called polar protic solvent, and the hydrocarbons are called the solvent that contain hydrocarbons are called a non-polar solvent. This is the example, and SN2 prefers this solvent, okay, speed up reaction, and this is the most important point. This is the effects of solvent, and what is the another point? Let's see that polar aprotic solvents. In polar aprotic solvent, the cation counterion of the nucleophile, but not the nucleophile. Polar aprotic solvents solvate the cation counterion but not the nucleophile. We can say that the polar aprotic solvent will not solvate the nucleophile, but its cations can be solvated bipolar aprotic solvent. Examples include this one and this one and this one and so on, DMSO and etc. You can see from these are the examples from which we can say that these are it can polar aprotic solvent can solvate these molecules. This is the another point. Non-polar solvents, benzene, carbon tetrachloride and hexane do not solvate stabilize nucleophile. This is the important point. SN2 reactions are relatively slow in non-polar solvents, similar to that in product solvent. SN2 reactions are relatively slow in non-polar solvents. Non-polar solvents have slowed down SN2 reaction. This is another point. These are the examples: benzene, carbon tetrachloride, and hexane. So the last effect at last requires a polar aprotic solvent. Okay, SN2 reaction requires polar aprotic solvent. No alcohol, no ammonia. This is the book. Let's describe the summary of the all lecture today. What is the effect of substrate? We had discussed that the methyl is a good substrate for SN2 reaction. Then primary carbon is a good substrate. Then secondary carbon is a good substrate, and tertiary carbon is a not good substrate. This is the least substrate. The best one is methyl, and then we have primary, and then we have secondary, and then we have tertiary. These are the best. This is the trend of substrate in SN2 reaction. That methyl substrate is good one. Primary good one, then primary, then secondary, and then tertiary carbon. Okay, here we have the second point, that is nucleophile. Effect of nucleophile is negative charge nucleophile is greater or better nucleophile than neutral nucleophile. Leaving group is why stabilize a negative charge. A substance that stabilize negative charge will be a best leaving group. And solvent need to be polar and aprotic. You know that solvent must have two polars and it must be aprotic. Aprotic means it do not contain OH and OH and NH2 group. This is the aprotic property. You know that it must have poles, but it do not contain NH2 and NH2 and NH2 and what? NH2 and what? NH2 and what? Please comment NH2 and what. So bye bye. See you.